Welcome to the Maintainable Software Podcast, where we explore the art of improving existing software with seasoned practitioners who have helped organizations overcome the problems often associated with technical debt and legacy code. I'm your host, Robbie Russell. On this episode, Jimmy Koppel, who is currently the CEO of Meerden and CEO of Up to Speed. Jimmy joins us from Cambridge, Massachusetts in the United States. Jimmy Koppel, welcome to Maintainable. So as you reflect on your experience in the industry, what do you believe are a few common characteristics of, dare I say, well-maintained software?
Sure. So for well-maintained software, you obviously have to start with what is the goal? The goal of a software is almost always to be used for some purpose, whether it's standalone as part of or as a library for other software. So it has to work. You don't say that, someone's going to complain, like, oh, I've got to get working. But then we have to look beyond that as to like everything gets in the way between delivering value, not just today, but in the future. And so you can look at its external qualities, like it has to be understandable and also it has to be evolvable. And those cover a lot of things. Like when you say it has to be evolvable, it doesn't mean like I can change it, but also means easy to change to the right thing and hard to change to the wrong thing. Because that brings in questions of robustness. So I can go over this a while because I actually quite recently wrote about this topic. I have a blog post called The 11 Aspects of Good Code. So I'm encouraging listeners to check that out. The 11 Aspects of Good Code. They want full detail in very poetic language. But I'll just say one more thing from there that I think not a lot of people think about, which is what a programmer is doing is that we turn thoughts and ideas into reality by code. And there's a pretty big process in which your thoughts become reality. And actually, people in the program synthesis community have, since the 60s, kind of formalized that and tried to figure out how can you get a computer to replicate that. And a really big insight is that a single thought can affect many, many pieces of the world and the code base, and well as artifacts out of the code base. So a really great aspect of great code is that you can make the system do as much for you if it's turning the thought into code. Some of my examples, it's like, so say you want to implement dark mode for your website. Do you have to go to 10,000 places and put the thing codes over and over? Do you have to go to a few places and put the codes over and over? But what even better, which is very rarely if ever done, is if you would actually just say dark mode and you actually have a mechanism that kind of infers a palette for you and puts in the shadow it needs to be and maybe adjust the size of things because colors and how large things needs to be interact. And if you can do that, then you're in programming bliss.
That's an interesting example because can you think of other examples that don't feel like the dark mode aspect? Like there's a general, like there's probably some patterns you can follow, like design guidance there to like be like, okay, there's using a certain color palette. These are kind of the, let's say that necessarily the inverse, but something that's going to work in a different context. It's like a on or off type switch thing. But I would imagine most developers aren't necessarily approaching challenges that just have kind of an on and off type of mode like that, or there's some sort of invert. I don't know the best way to describe that, I guess, in sort of like a toggle like that. Do you have another example?
Sure. So one that comes to mind very easily because it's an exercise in our course is there's a very famous piece of code from, I believe, Quake 2 or Quake 3 called the inverse square root, which computes 1 over square root of x, which is very important to a number of physical calculations, such as lighting. And so there's a very famous code snippet that looks like absolute magic. And like it does this weird stuff with like converting the float to an int and then doing some bit shifting and handing it with this really weird constant. And like you can try to reverse it, and like there's a whole Wikipedia article on the fast inverse square root, and you can figure out that it's actually is doing like a quick estimate and like 1 round of Newton approximation. But I want to focus on the magic constants. Like there's really weird constants that it uses there. And how do they come up with this? And the answer is that, well, it's like some approximation lets you solve for something that's almost optimal, but you can search nearby for the thing that's actually optimal and test it, and you can test alongside a large number of the possible inputs, realize this one choice of constant picks you the best thing. And so that is a very large thought process that goes into that single constant, which is just there, to the extent that you have this entire Wikipedia article about this 5-line function. And so question we give students is, how do you embed that more in the code? And the answer is that, so what if instead of checking in as your source, this magic 5-line function, what if you like took whatever program you wrote to find the optimal constant to use there, because I'm sure there's a program, and you check that instead, J, which is a constant, and that's your true source.
You'd also mentioned like how trait of maintainable code is that it's evolvable, and you mentioned that it's easy to change the right things, but it's also, I'm assuming, it makes it more difficult to change the hard things or the things you don't want to be.
Yeah, I said easy to change it to something else that works and hard to change it to something else that doesn't work.
And can you share an example of like when you wouldn't want to change something or where it's kind of intentionally hard?
Sure. So if you have a program that crashes when you pass negative numbers, it'd be very nice if it was going to be blindly obvious, like when that can happen and when your variable's passing a negative number. You could have a fancy type system that has separate integer and positive number types, or it can just have certain variable naming. It's like I have a variable called milliseconds, and I have another variable, and it's passed to a function which takes a keyword argument called difference. Actually, wait, let me take that around. Let me reverse that. I have a variable called a time difference, and I am passing it to like a keyword argument called time elapsed. One of these sounds like it's always positive, and one of these sounds like it could be negative. That should stand out. And in fact, something where you use keyword arguments, it's much more likely to be caught in code review versus positional. So that's an example of making it harder to change something that doesn't work. Very simple.
And how do you kind of weigh up when you think about something you'd also mentioned, and there's a couple of other things we'll dig into related to that article that I had read that you had written, related to, the code needs the work to be worth, I suppose, being maintainable and to some extent. Where do you kind of delineate? Do you have a common definition when you're working on projects, or how you talk with your students taking your courses to think about what their definition of done is? Like, what is that? Because you could keep polishing and massaging code. Where's that line for you?
It's not the thing we talk about a lot. It's like code is never done. Every project has its huge backlog, and then half the field of product management is just pruning that backlog, things that are actually important. So I don't know much to say there. It's like, do you need new features? Do you want new features? And do you want to fix bugs? If so, your code's not done.
It was in terms of like, is the current objective or the ticket you're working on, the feature enhancement, is it done enough as a code base that you can move on to the next thing, knowing that the code base as a whole isn't done, but in terms of like this particular objective is seemingly done enough that we don't need to keep optimizing this?
So I'm not sure I really understanding your framing and context. Because so like I'm hearing like, is the code base done? Which the question is, the code base done? Which I'm transferring my head to, is the project done? I don't know if you're asking me. It's like oh, it's like there are things like, oh, it's like I wrote this feature and it works, but it only works with people who are under 100 years old. Do I need to fix it? Is it done or not? Like, there are questions like that I think are mostly not that interesting. Like in that case, like that's the example. Like if your feature only works with people 100 years old, you probably did something stupid, and you shouldn't have stupid things in the code that's probably are causing other problems.
I think it more in terms of if you're working on a piece of software where the end user is, or the customers or the client that you're working with is requesting some functionality improvements, and there's a gray area about how far you go when there's like managing scope for that particular feature. And so you might say it needs to work for the 100-year-old person. Step away from that example, but let's say we need to add some functionality that's going to generate an invoice. And so you get the part where it generates an invoice. The code quality that can drastically differ in terms of like, when do you decide the invoices are being created, but at what level is it optimal enough to consider this good to move on and we can come back and iterate on it later, versus
there's a question about whether the feature is done. There's a question about whether the code is acceptable for checking in.
Yes.
So these are two different questions, hence some my confusion earlier. So let's prefix. So every project has different needs and standards in terms of code quality, and depends on a lot of things. You can probably think of 5 of them top of your head. And different parts of project, also different standards. I tend to think that most people have their standards too low, or even they want to see them higher, they wouldn't know how to raise them. So I can tell you a number of factors that people maybe they try to count, but they don't do it properly, that would tend to push the standards up. So a really big one is so first, someone needs to read that code, like your reviewer or yourself, in 5 minutes. And there's kind of a huge gap between like the code, where the code looks like I just kind of like English, like I just wrote down, make invoice, make fields, and then the thing lays it out for me and makes them flow, versus like draw these boxes or even like put down these fields. Then when they click this, get this value and put it here. And so there's a huge range in terms of how much you need to mentally translate the code into thoughts to read it and vice versa to write it. And I think people tend to not realize just how beautiful you can make it. And when I say beautiful, I don't mean like, oh, hey, I'm like painting. I mean like it is pleasant to work in this code base. I do not need to spend effort. I can do very interesting things very quickly. So the fact that you can have code that is absolute pleasure to work with, I think many people just never reach that. And so that will tend to lower the standards. And another thing is it is quite predictable how much the quality of a particular piece of code will impact things going forward. And you can look at code as a graph in a number of ways. And so there are very direct things like the relationships like this function calls this function, which means that, if you were to change something in that function that changes what kind of values it expects, that it changes its callers, that creates costs for changing that thing. Then it connects in other ways, like we have a certain name convention, or there is a place it's all over the code that we're assuming that images are on the same machine in a folder with this name, and you can look at where the assumption spreads. And you can write that assumption that images might be a certain place instead of the same machine. That's like not a single place in the code, that kind of on the side, but it's connected to the code in a lot of ways. And so you get this whole graph structure of every idea and thought and assumption that went into the code and how they're connected to each other into the code. And the trained eye can look at a program and see these connections. And that lets you predict quite well the cost it will be to change something, as well as how much someone will need to read this going forward to understand something and change other things. So based on this graph that you can learn to see, that it does a lot to tell you the long-term consequences of leaving the code in a messy state.
Hey folks, it's me, Robby. I want you to take a moment and close your eyes. Now picture your code and your applications as a symphony. Now to keep that symphony playing smoothly, you need an orchestra of tools. That's where our podcast sponsor, AppSignal, takes center stage. They combine the elegance of error tracking, the precision of performance monitoring, and the harmony of logging into one symphonic suite. Whether you're composing with Ruby, jamming with Elixir, orchestrating with Node.js, or harmonizing with Python, or maybe even a little bit of flourish of JavaScript, AppSignal's got the sheet music for you. And here's the crescendo. Plans start at just $23 US a month. That's got to be music to your budget's ears. Plus, they're certified ISO 27001, and they dance the GDPR and HIPAA compliance beats. So don't miss a beat, my friends. Head on over to appsignal.com and tell them that your good friend Robby from Maintainable sent you. Now, open your eyes and let the symphony of smooth coding begin. Let's get back to our show. I know that your article, 11 Aspects of Good Code, one of the topics you touched on in there was that good code makes it easy to recover the intent of the programmer. Could you talk a little bit about what you mean by that? I have a general idea about it, but for listeners in terms of thinking around, trying to understand why something was there, but maybe what the rationale or, in your words, the intent.
So I think this kind of theme been mentioned a number of times today. So this refers to something called the embedded design principle, which I first publicly wrote about it in my blog post from, I think, 2018 or 2019, my favorite principle for code quality. And so this goes back to the idea that there is a logical process by which your own thinking and intentions, as well as facts about the world, the environment, and assumptions get translated from high-level intentions, low-level intentions, to plans, to details, to your intentions for specific code blocks, all the way down to the individual lines, all the way down to the white space. And I step back a bit and quote from a great book, Zen and the Art of Motorcycle Maintenance. It says, a motorcycle has the idea of a drivetrain, but there is no part of the motorcycle labeled drivetrain. It's there's actually not even a part labeled transmission. There's specific gears and cams. And yet you need to understand this idea of a drivetrain toward a motorcycle. And so as you're tightening a screw in a certain place, what you're really doing is you're operating not only on the concrete piece, but also on the high level structures, which are composed of patterns of pieces for some bigger goal. So This can, on this one level, be tightening a screw, on this level, saying you're fixing the drivetrain. And so this happens in code as well. It's like if you're describing your task to someone, you will not say, oh, well, I'm replacing these 5 lines with this one line. You might be saying, it's like, let's say I'm replacing this specific instance of something with general functionality that it does it. We not say, well, I'm like deleting all these braces and moving these things around in this fashion. You might say, well, I've extracted a common superclass of these common piece of functionality. And so always when you're working in code, you're working in higher ideas. And so there's a lot that can be done when the code is closer to those ideas. So one example on thing actually, I wrote a long Twitter thread at the end of last year based on, I went and walked an MIT class and kind of gave a guest lecture doing code reviews and just full of examples. So think of the code like new date dot time, like it's a current time, less than something plus 60 times 60 times 24 times 3. And which, if you follow that is 60 times 60 times 24 times 3 is the number of seconds in 3 days. To this code, you have to think about, I'm checking like if this time is within 3 days of this other thing. Then you have to translate that to like a time plus an addition. And then you translate then this to seconds and like come up with the formula for computing. That's the number of seconds in 3 days. Thankfully, what it didn't do is actually put multiplication in the code. They didn't hard code that number of seconds, which, oh my God, I hope not many people have learned to recognize that. So it could have been worse. But like now someone reading that has to undo the mental process of seeing that thing, recognizing it as the number of seconds in 3 days, and then figuring out the actual intention. And like you can just have a small time comparison library unless you write like
3 days from now, or
like time dot now dot until this time plus days of 3 or something like that, and that makes the code closer to the level of thought. And now if you want to change the intention of like, oh no, I don't want to check within 3 days, change within 4 days, you don't have to do this translate the code back to the thought then back to the code thing. It's just there.
That makes sense. And the example also about trying to avoid doing something like just taking the calculation of seconds and just sticking that in there and being like, what's this weird wild number here that you may or may not remember? I don't know how many times I've ever seen like 86,400 in code and being like, how many was that? So that it does pop up more than we like to admit. In that same article, you also mentioned something I was really curious to dig into was good code hides secrets. What kind of secrets are we talking about here? And do you want to share any personal secrets with our listeners?
No, it's because of secrets. So secret's a term which it's very closely related to the term information hiding, which that I think has penetrated software engineering circles pretty well. And secrets, I think, would be recognizable to most academics, and it has penetrated software engineering somewhat, but not extent that encapsulation information hiding have, but they all come to the same place, which is their origin is some work in the early 70s by David Parnas. So here's one of the stories that's spawned the idea of secrets. It was told in this article called The Secret History. It's a pun, The Secret History of Information Hiding. And about 1969 or 1970, David Parnas was working for Philips in the Netherlands, and they were working on an operating system. And you see these two guys, Jan and Johan, having lunch. And one asks the other, it's like, yo, what does it mean to open a file? It's like, what do you mean it does mean to open a file? Like, you can't open a file, you can't read from it. I'm like, no. Like, tell me like how it's laid out on disk. Because I'm working the compiler, I need to write the open function, or I need to check if it's. So the operating systems guy takes a napkin, starts like showing the bit structure of files, and David Parnas sees this, and he like has a feeling that something is wrong. He tells him this, and like they're like, "Go away, we're getting work done." And so this napkin gets taken upstairs, gets 3-hole punch, put in a binder, and the compiler team, because this is a few decades before continuous integration was a thing, compiler team writes their open functionality, assuming the files have a bit structure. At some point, that structure changes. They put the compiler and operating system together. Lo and behold, they don't work. And so David Parnas was, for a few years afterwards, racking his brain and thinking, like, well, what could I have told them? It's like they did need to get work done, but clearly, like, there are consequences of this. And so the idea he's come up with is secrets, which is you need to view, the line that I have is when you call a function, you're not calling that function, you're calling it function and all alternative versions of it that satisfy the same spec. So the files, like, you're not building a compiler to link with the operating system. You're not building these two components to link together. You're building a compiler that links with anything in this amorphous space, operating systems that satisfy a certain spec. And like up to the operating system to pick like which version they're doing and how they're laying stuff out. But like they have some rules that they need to follow and they can do anything within that. And your thing doesn't really work in some sense unless it works with all of them. And that sense particularly is like, if it's not possible to know your function works unless you read 30 other functions and go like 5 levels deep in the stack, then there's a sense in which it doesn't work, period. Because it needs to be able to work if you like only read the spec or the documentation of the things that you're using. So what they should have done in this case was say, it's like, all right, the operating system team is going to provide, they have some layout of files. You don't know what it is. You need to work with anything they give you, and they will provide some operation on that called open that you can call. And maybe you can try to inline that in. But if your thing is like making assumptions about certain bits being in certain places, and that's fragile and that's not guaranteed, it's not a stable guarantee. And we'll just say your program is wrong, whether even before you look at their code and see whether it works together with whatever they come up with at the end. So here are the formats of a file structure is an example of a secret.
Can you think of an example? Because admittedly, I feel like that kind of dove down into some low level stuff that my brain's kind of like imploding a little bit as I try to wrap my head around it. And that's okay. But for some of us people that work in software, just a different level of the stack, yeah. And where, like I'm primarily working in like web development, do some shell scripting, things like that as well. But like, can you think of an example of like a secret that you'd be like, well, it shouldn't know that much far down below, but I'm just trying to think. I didn't know if you were kind of speaking to like credential type information or.
So one example that comes to mind is privacy settings. So actually, no, I'll use a simple one, say like ID order. That's pretty universal. So you have some policy that's something that generates some entity, whether it's like posts and assigns IDs to them. And all it says is these things have unique IDs, but you know that actually they get IDs in sequential order. Something you never want to do is to compare to the IDs of two things. Say, if this thing came later, then it was made later. Never want to say, like, give me the most recent thing and sort by ID. If there's no timestamp or other thing that tells you that information, you don't want to say, oh, I'm going to sort by ID and declare myself done. You want to say, I can't do this. Or if I do this, then I'm making something very fragile and to put a giant red sticker on it.
That's a much more helpful, example there. And now, is that because, if assuming that if you're working with like a typical database where you have it set up to increment the number, you're saying it's not a reliable number to work off of?
So if the thing breaks, you need to say if the thing breaks later because it changes. So like you switch from database to a distributed database, you do some kind of sharding. Now things are not strictly increasing by a timestamp. You want to say, it's the backend team's fault for suddenly before these things went in sequential order and now they're not. It's their fault for changing that. Or do you want to say front end team's fault for having assumed the first place that they were given sequential order?
That makes sense. Or you need to later upgrade from like just an incremental ID to like a GUID or something, and then I don't think you can sort that.
And you could kind of have expectations like that kind of guide your default behavior in the same way that's in actual legal contracts. They're like default things. Like you don't need to write down this thing does what it says it does in order for that to be, that's a default. You need to write it down that it doesn't, it might not do what it says it does, as you've probably seen 1,000 software licenses. So like in this case, like the default for an ID is that just like it's an ID, it's unique, no other guarantees. If they don't say they're in increasing order, then it's the person who assumes they are. It's their fault for using them that way.
So for everybody listening, you should always be sorting by some sort of creation timestamp, possibly. But that definitely is a good point there. One of the other topics I was looking forward to speaking with you about is, I know that one of your new business ventures is Up to Speed, which I believe aims to help teams onboard developers faster. Could you provide our listeners with a little bit of background on what you're hoping to accomplish?
Yes, this is something that we just started working on, and basically realized that this big problem of onboarding that we've heard from multiple people we've talked to that at their company, it takes new engineers 6 months to become a net positive, let alone fully productive. And that's obviously massively costly. And in a lot of ways, a core problem here is about code-based reading. That's like you start a new job, every task you do, it's like, I never prefer, it's like, all right, so when you join a new team, And it's like I spend like one day or two implementing the feature, and then 2 weeks reading other code and talking to people to make sure it won't break in unexpected ways. So our goal is to create the best system out there for learning a new code base.
And how are you hoping to do that? Like, is that, keep that as an open-ended question there, I suppose.
Yeah, yeah. So I'll just tell you like one of our big ideas is when you dive into a new code base, it's often very hard and frustrating before it becomes fun and enjoyable. And that's because it starts off hardest and gets easiest. Like you look at a code base, like you look at a function that's modeled to what you want. And actually, like you're trying to send emails to users, you look at the send email function, and actually it doesn't do that. It actually, enqueues something, sends to the backend server that sends different backend server, and then there's logging in there, there's permission checks, there's a million other things. And like you're just wanting to learn like what kind of email does it send? And like what's like the sending email part. So what you just encountered is a problem of sequencing. That's code that does different things is very intermixed, and it's often very hard to find a handle on what you can read first that you'll actually be able to understand and get that small win feeling. So one of the core ideas of what we're working on, still super duper early phases, is try to create a mapping between the ideas behind the code and where in the code they realized, and then also find the dependencies on them. And this can at a minimum help you read things in order. You can actually learn things instead of look at a piece of code and like, there's 30 things going on here. I can't make anything out of this. Just like I can seek and re-experience very often my feeling looking at a code base. And as levels beyond that, thanks to all the AI that's coming out, what we're doing is sometimes there is no existing part of the code base. You can look at it and just has the parts you want, plus things you already understand, but nothing you don't understand. But you can do things like you can simplify away the edge cases, you can delete the error handling, and just show you the happy path, and kind of simplify and make your own modified version of the code base that just has the parts that you need to learn. Even if it's not the real thing, it makes it far easier to come back later after you learn a lot more and understand the real thing, like reading a book, as opposed to like decoding an ancient text.
Sure. I think one of the, I talked to a lot of people about onboarding on the podcast, and it's something that in my world I deal with a lot with our team because we work on client projects as a consultancy. So things come to us in a current state of we may or may not have access to the previous developers or current developers or original developers. And it's been passed around a bunch of different teams over the years. And so that context, that intent sometimes gets lost quite a bit. And then there's also another issue with a lot of code is that there might be code that it's in there, but it's not necessarily being used that much, or could potentially be ripped out at some point. There's some dead code or some functionality that's lightly used, but you're new to the project, so you're not necessarily thinking like, is this safe to remove?
Yeah.
And you don't necessarily have anyone to ask.
So
it's like a tricky thing, I think, probably for any automated tools to make sense of.
A small story I have that is something that happened at IBM 10 or 20. I think we were 20 years ago, 15, 20 years ago. It was IBM Tangram, starts with the T. Yeah, some other products, they looked some code and spotted a bug in it. I'm like, this looks really bad. And one engineer spent 6 months tracing down that bug and figuring out exactly what happened. He realized, well, it will only happen if this particular setting of compiler flags is set, and this particular setting of compiler flags is only set for old machines that we don't support anymore. This thing is no longer relevant.
We'll be back with our interview with Jimmy in just a moment. Hi, it's me, Robby. I just wanted to take a quick moment to say thank you for making time to listen to the Maintainable Software Podcast. If you're finding these discussions valuable, please consider sharing a link amongst your peers and or writing a review on Apple Podcasts to help spread the word. I think you can even do that in Spotify now. Also, is there someone you think I should be interviewing on Maintainable? Shoot me an email to Robby with a Y at maintainable.fm and state your case. And now, let's get back to our interview with Jimmy Koppel. Spend 6 months on something that's actually not even needed to be worried about anymore is definitely a thing that happens. I'm curious about like if you're building some functionality, or what's your take on like the current state of with the tool that you're working, the product you're working on, up to speed, and in terms of like now that a lot of say slightly larger organizations might have a collection of microservices and things interconnected, and they're not all part of like the same Git repository. And so there's this, and the other thing I always think about with onboarding is that like a team might be bringing people in to work on the product or the software project, but they might be coming in to be worked on different areas of the code base. And so the onboarding process might need to be a little bit unique depending on the skill level of the people coming in and where they're getting hired or what team they're getting assigned to within a large ecosystem of microservices, or maybe it's a big monolith, but there's still a lot of like departmental type aspects to it.
So I think you're kind of getting at the tendencies of learning. Like, so there's a concept called push learning versus pull learning. Push learning is, so you say, like, I want to start working in React, and so you go do a full course in React or read a book about it. And pull learning is like, I want to work on this specific website that uses React, and like every time you need to do something new you haven't done before, you try to find some tutorial on that thing. And they both have their time and place. I just think that humans tend to systematically have a systematic bias against systemic tend to focus on very short-term things. It's very hard to get the motivation to push learning, even when it's actually is the most efficient for you in the time frame of 1 month or even 1 week. But anyway, that aside, it's like, so like, how do you not have someone like learn whole code base, the piece they need for whatever the job is? And something that's really nice about having software starting to generate the onboarding experience, that if we can get high accuracy at building this big graph of the ideas in your code and the dependencies between them, then and also if we can then have it look at a task and kind of guess what things are needed, then bam, you now have a learning path just geared towards what you need right now. So we can actually do pull learning, but with fewer of the downsides that come with pull learning traditionally.
In that sort of thing, do you feel like there's this not too far off in the distant future where, as people bring in new hires under their team and they're starting to work in a certain area, they can interact with some AI-esque technology that will help them get up to speed with what they're kind of focusing on, and rather than having to learn things that they're not going to be touching anytime soon, and then at least get those small early wins, and then they can continue to uncover different areas of the code base versus kind of setting up onboarding material that's kind of generalized for anyone that comes in the door.
Yeah, that's right. And it's just general fact that as things become more automated, you're able to make them more tailored and personalized.
One of the things we started doing with a couple projects is we've set up like drip email campaigns for some projects. Like, okay, so it's just like, which is for a small internal team, it'll be like, all right, for the next 4 months, we're going to drip you some little details and just drop it in your inbox. Just here's some things to be aware of, and you can easily hit delete because you already know about it. But those are very much coming out of a long history of like, I want people to know these things, but they're not going to remember that they read it in our handbook the first couple of weeks when they started their job. But like, how do we reinforce these ideas or these concepts, or point out areas of the code base that might be, hey, this is a really weird area of this one certain client project that might be useful to wrap your head around at some point. But I think it's like, how do you think about education? And it's one of the other things I want to talk about as well is the work that you're doing at Mirrodin, but in terms of like training and bringing people up to speed, but also reinforcing ideas that they may or may not need to be aware of, but while keeping it kind of ambiently in their space or their headspace in some ways, getting it to them somehow, even though it may not be like a short-term thing that they're necessarily need to be concerned about. Could you tell us a little bit about your work with Mirrodin? What types of consulting or coaching services are you offering software engineering teams?
Mirrodin is the code quality company, and we turn good software engineers into great ones by teaching them some of the software design things talking about today, as far as like understanding how to make your code more resemble your high level intent. But we do this with lots of examples drawn from real code bases and projects, and a lot of exercise to help you really internalize it. So our flagship offering is the software design course, which you can find at mirrodin.com. And we get testimonials like one person said they learned more from 2 weeks of the course than they had from 2 years of grad school.
Oh, wow.
People saying like they just go through the first lecture and it changes their idea of software. So like a really big niche is like, once you pass beginner level, most of the things that you'll find for software engineering are tech specific, and there's not really that much out there about how to write great code that's going to be maintainable and less prone to bugs and less work for you and others. And that's our hit the general big ideas past beginner level.
Nice. I'll definitely include links to that in the show notes for people to check out. And that was a software design course?
Advanced software design course.
Advanced. Okay. Find that in the show notes there. Couple of quick last questions for you, Jimmy. Is there a non-programming, non-technical book that you find yourself recommending to people on a regular basis?
So there are a couple of learning science books that I bring up a lot. The two books are Make It Stick and How Learning Works. Yeah, and so I think both of them are written by various learning science professors, sometimes in collaboration with not teachers. And How Learning Works is a less well-known book, but it's very good. And there were a number of like it introduced me to some whole areas about learning, and that's were like hugely important, really affected my thinking that I've not seen discussed in any of the other non-specialist writing about learning. As a little warning, do not confuse the book Make It Stick with Made It to Stick.
Hmm.
Made to Stick by the Heath brothers is also a very good book, but it's about like marketing messaging, whereas Make It Stick is about learning. I like
Okay.
them both, but
That's the one I'm thinking of. Yeah. So, okay, make it stick. I'm going to look both of these books up. Something I'm curious about is was there a point, did you always know that you wanted to kind of be in an educational type of role in this type of field? Or is there or was that something you felt like was early on in your career or your life? Or like, I think I enjoy teaching people things or showing them things,
no.
or was it
So
something
so it's been in line with my mission, but the educational angle, something they did just kind of happen. So one of the greatest things that happened to me is that like a lot of people go through life searching for life purpose. And I basically woke up with it one day in about May of 2010, which is I woke one day and I realized the world does not know how to write good software. And I was thinking about like all the stories I've heard of endless software rewrites and delays, just stuff not working and Y2K. And I thought I would make it my life mission to make the world of software better and formulate the goal of to reduce the global cost of software maintenance by a factor of 100. But the whole time, most of my career, I've been focused on the tool side. It's like, how do you write some really smart tool that's going to look at your code base, make it good for you, fix the Y2K problem for you, or coming up next decade, fix the Unix epic problem for you, and as well as more interesting changes. So my whole career has been focused on software tools. My first company, which was total failure, was automatically fixing bugs in other programs, program repair. It's such a good idea. It only took a year to figure it was a bad business. My PhD was on the more meta level about not less about building specific program transformation tools, but how do you, once you build them, how do you make them more general? It's like how do you make your thing work in 5 languages instead of one? That was my master's thesis. But I came into the educational angle. It's kind of at some point I was reading blog posts and I'm like, I was reading other people write blog posts about software quality and design. Like I'm just thinking I understand this stuff way better than these bloggers. So why don't I do it? And then I was looking to start a business school in grad school that was going to be more impactful than just me writing some code on the side. Because I was started off just doing, I just, went to grad school. My first year I was doing part-time work for my former employer. And, it's realized that I can make way more impact, not by being a good programmer, by making other people's good programmers.
That's very admirable of you. I'm curious about kind of get to this inflection point in your life, and you're thinking, I want to, and specifically around, wanting to reduce the maintenance cost of software by, I think you said a factor of 100. Do you have like a philosophical concern or thought around software development in terms of like trying to, like, one of my missions is to help companies avoid rewrites or just projects avoiding rewrites, because I often feel like they're not really solving the underlying problem. And I'm like, if you have the same team and they're going to use a new tech stack or something, is it a good decision just because you think it's going to be different the next time around? Maybe not. Or is it like, I always feel like there's this concern that like, well, we need to do away with I'm air quoting the old and move over to this new thing. And we'll do all the things we were supposed to do right this time. But I always don't feel like that ends up necessarily manifest. The rewrites are problematic as themselves, but like, do they actually change their behavior as a team or how they think about what quality and keeping it maintainable going forward on that particular project? Like, how did you kind of come to this conclusion yourself?
Conclusion about the world of software really sucking.
That seems relatively easy, I think, for people to wrap their head around. I think it's more of everybody else's code is horrible for the most part, right? And then not necessarily true, but I think more in terms of like reducing that maintenance load on software projects. The long term, we need to go back and do that kind of stuff and avoiding the rewrite.
I definitely have a spiel there. Before I give there, I just want to recommend a blog post. This is on our Muirden's reading lists that Muirden offers students. Herb Caudill, Lessons from Six Software Rewrite Stories, which is the common wisdom about never do a rewrite is too simplistic. There's some stories where it actually went very well. So the philosophical aim is that the world runs software. And when software is hard to change, so is the world. And as programmers, we are building the world. We are some of the people creating the things around us. And you do not want to live in a world where all the buildings are physically rotting and all your devices don't work. And similarly, you do not want to live in a world where all your programs don't work, where there's really bad weather, and then suddenly an airline just cannot manage people for a full week. That happened last year with Southwest and their software. You do not want to live in a world where it hits, I think it was the year 2036, 2037, and lots of things stop working, or all new development has stopped for a few years, people remediate. And so it's like we like you look at what we have around us compared to what we had 100 years ago or 1,000 years ago. Like humanity's come so far in creating so many things. And like we owe so many other people for having built great things that work, that can be updated, that other people can understand, keep building. And so we owe that to everyone else into the future.
It's kind of a little bit of thought around just appreciating the amount of human time that has gone into the projects that we interact with. So I think there's always a little bit of like when software comes to, like say in my world, when it comes to me, I've always tried to be understanding that the developers that originally worked on this code base had a certain level of skill set, certain constraints that may not have been outside of their control. And I want to be empathetic towards them and at least acknowledge, like understand that I don't know the situation, how the code entirely got to be the way it is, but it is the way it is now. And we can't undo the past. But I think about trying to think about how do we pick up the pieces and move it forward and iterate and improve things. And so that's why get to talk with people like you about this kind of stuff to get a sense of like how other people think about these challenges, because we don't always get to write the code the way we wanted to from day one, or some people don't even, as you said, don't even know what that might look like because they haven't had a good experience of their skill levels only up to a certain point so far. Kind of quickly wrapping up, thanks for sharing these books. I'll definitely include links to them as well in the show notes for everybody. And where can listeners best follow your thoughts and ruminations about software engineering online?
Sure. So I have my blog at Path Sensitive, Path PATH Sensitive, because spelled like the one word, no hyphen, no space. PathSensitive.com. It's my blog where I write about a number of topics, but primarily about advanced software design ideas, like what is abstraction? And what is abstraction? On maybe things I've talked about today, the 11 aspects of good code. Sometimes I write about other things. I have a new blog post coming up soon about why the vitamins versus painkillers metaphor is totally wrong, because vitamins actually outsell painkillers 3-1. I also sometimes tweet at Jimmy Koppel. So sometimes I put actual content there. It's like, there's a video that came out early this year, not too long, not something that long ago, about composition versus inheritance. And then I gave like a 20 tweet thread trying to explain like how what he's saying corresponds to the actual type of objects and about why the video is totally wrong. So sometimes I post a lot of deep software engineering content there. Sometimes just make jokes about category theory. It's like, I used to think category theory ideas like free objects were useless. Then I found Craigslist. Now I use free objects every day.
Well, great. I will definitely include links to those for people in the show notes as well. And with that, it's been such a delight having you join us on Maintainable, Jimmy. Thank you so much for stopping by to talk shop.
It's been a delight to be here.
Awesome. Thanks again. Maintain